Hi, this video is about naming ionic compounds. All right, so an ionic compound, hopefully we all know now, is between a metal and a nonmetal. And so we are going to have a cation and an anion. You always name the cation first. So this is going to be your metal, or it could be the only other positive thing here could be the ammonium ion, that polyatomic ion NH4 with a positive 1 charge. Always name that first. And then second in the name is the anion, or what has the negative charge. And this is going to be a nonmetal, so it will either be like one nonmetal, or it could be a bunch of nonmetals together, even maybe a metal nonmetal, which is the polyatomic ion that will be on your list. All right, so let's go ahead and start with the metals. Usually this is pretty easy. The name of the metal is unchanged. So here we've got the ionic compound sodium chloride, and the Na, we just say sodium. Here we have CaCl2. We say just calcium. There's nothing we have to do. Look at your periodic table. The names of the elements are under the periodic table, but hopefully by now you know most of these elements. KCl, potassium. ZnCl2, zinc. These are all chlorides, so we would end chloride at the end. AgCl is just silver, and Al is aluminum. All right, so you just say the name of the metal. That's pretty easy. Until you have a transition metal. Now remember that these transition metals can have variable charges, and in the name, when they give us the name, they give us the charge, and they give us the charge as in Roman numerals in parentheses. Well, now it's your turn because you're naming, so you have to start giving the charge of that transition metal in Roman numerals. So the positive charge of that transition metal is shown with your Roman numeral in parentheses. So here, this is iron 2 chloride. This is copper 1 oxide. This means that the charge on the copper is 1. And this is lead 4 oxide. But wait a minute. How do you know the charge on the transition metal? We have to do a little bit of figuring out. The thing that you need to remember is that that positive charge on that transition metal has to match the negative charge on the nonmetal portion of your ionic compound. Remember, the positives and the negatives have to match. So if we have SNO, SN is 10, it's atomic number 50 if you wanted to look where it is. We're going to have to name the charge on 10. So we're going to have to know the negative charge. All right, oxygen is -2. Look at your periodic table. It's 2 away from a noble gas, so its charge is -2. The tin's charge has to match that -2 to cancel. So if this is -2, the tin has to be a +2. So the name of this is tin 2. Here we've got NiCl2. It's nickel. Look on your periodic table. It's in the D block. Nickel is a transition metal, and we can't just say nickel. We have to say what the charge of nickel is, and we're going to have to look at chloride's charge. So look at chlorine on your periodic table. It's a halogen. It's 1 away from a noble gas. It has a -1 charge. So 2 times -1, we got 2 of them. The overall negative charge on that is -2. So what must nickel's charge be so that it cancels that -2? So it has 0 overall charge. Nickel's charge has to be a +2. So its name is nickel 2 chloride. Here we've got CuSO4, and you've got this 4 down here. That just means in this polyatomic ion, you have 4 oxygens. It has nothing to do with the number of sulfate ions. How many sulfate ions do you have? Well, look at your polyatomic ion chart and see that sulfate is SO4. We only have 1 sulfate. What's the charge on sulfate? Look on your sheet. It's -2. So we have 1 sulfate, not 4. We have 1. And it has a -2 charge. So copper's positive charge has to match the negative charge. So this is copper 2 sulfate. All right. So we need to practice this, but you need to keep the idea that the positive charge on the metal has to match the negative charge on the nonmetal so that this ionic compound has no charge. When you're done writing a formula, you should not have any charges up here. Okay. All right. So now let's talk about the nonmetals. All right, so we got the hard part over. Those transition metals and figuring out their charge, that's the hardest part. We're done. All right, if the nonmetal portion of your ionic compound is not a polyatomic ion, so it's just one element, it ends in "ide." And so NaCl is sodium, just name the metal, chloride, sodium chloride. Kf is potassium fluoride. CaO, calcium oxide. MgS, magnesium sulfide. All right, so easy. The ending just changes to "ide." All right, if you have a polyatomic ion, and that is your anion portion, you never change the name. That's what's good about polyatomic ions, and you've got the list of them in your packet. You don't have to change the ending. You just keep it the way it is. The only positive polyatomic ion we have is ammonium. So let's just go ahead and look at this one. This is ammonium chloride. We didn't change the name of ammonium. It's one nonmetal, and we're changing its ending to "ide," ammonium chloride. All right, our metal portion of this is potassium. This whole SO4 is the nonmetal portion. It's more than one element. Go to your polyatomic ion sheet and look it up. What in the world is SO4? Oh, sulfate. Good. Potassium sulfate. Got it. All right. Silver. This is more than one atom here. NO3, part of the polyatomic series. Look it up. Nitrate. Silver nitrate. Now this looks crazy. We've got two metals here. Well, the first metal is your cation. So that's potassium. And then this whole other mess in red here, even though that's a metal and you've got this oxygen here, that's got to be a polyatomic ion. You need to kind of recognize when you have a polyatomic ion. Go to your sheet. What is MnO4 again? It's called permanganate. All right. Whoa, 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 whoa. Look at this mess. Well, the magnesium is your metal. This whole mess is the negative portion of it. It's got to be a polyatomic. Goodness gracious. And you go look it up and it's acetate. So this is magnesium acetate. Notice on this slide, I didn't put any transition metals. So we don't have any Roman numerals that are going along with our metals charge. All right, so that is our naming ionic compounds, and it just takes practice. It took me a long time to learn all of your names. It's going to take you a little while, and we're going to practice a lot all year long learning the names of these ionic compounds. All right, so practice in class. You can watch another video that I've posted on naming ionic compounds and things, and figuring out the charge on those transition metals, and we'll see you soon.